Hello friends, welcome to my channel. Have you ever tried to change the LED brightness or smoothly changing the motor speed, right? It might look like the voltage level is getting adjusted, but no. It's actually turning the power on and off very rapidly such that it is non-detectable by human eyes. So this is called the PWM. And in this video I am going to discuss that how PWM actually works and with the help of a circuit simulation as well as with the help of practical demonstration using Arduino. So let's get into the video. First of all, let us discuss about the PWM, which stands for pulse width modulation. So PWM basically means to make the digital signal behave like an analog signal, right? Although PWM is not exactly an analog signal, but we try to make the digital signal behave like an analog signal, right? And instead of outputting the steady voltage, the signal, that means the PWM signal, rapidly switches the voltage level between high and low values, and because of that we are able to get the analog behavior of digital signal because of this rapidly switching, right? So for your reference I have attached the three figures with different duty cycles: 50%, 75% and 25%. So 50% duty cycle means for 50% of the time the signal will be in on state, so this upper edge is representing the on state and this lower edge is representing the off state, right? And for 75% of the duty cycle, the signal will be in 75% on state and 25% in the off state. Similarly for the 25% of the duty cycle. And in this figure I want to tell you that how we can define duty cycle. So here F means frequency of the signal and T means time period. So duty cycle is defined as the on time divided by the total duration time. So this upper edge is for the on time and divided by the total duration time. That means from this point to this point, right? This is the total duration time or the time period of the signal, this time period, right? So duty cycle is equal to on time divided by the total duration time. And please note that duty cycle is always defined on the on time, not on the off time. This is the off time for lower edge, right? And time period is fixed by the PWM frequency. And duty cycle means for how much of the period, that means total duration time, is spent on the on time. So that means duty cycle, right? So in this way the duty cycle is defined on the on time. Now let us move on to the circuit simulation of the PWM. So this is a circuit simulation for the PWM, right? In this circuit I am using the LED and the circuit which is generating the PWM signal. This yellow part is the circuit which is generating this signal, right? It may be your microcontroller also. So currently I am using the width of 30%. That means for 30% of the time the signal is in on state. You can see from the graph. And for the 70% of the time the signal is in off state. Now let us try to change the width of the signal. Let us change it to the 80%. So now you can see the changes. For 80% of the time the signal is in on state, and for 20% of the time the signal is in off state. And for this circuit I am using 5 millisecond of the period. That means total time period is 5 millisecond. So the frequency will be come out to be 1 divided by 5 millisecond. That means 200 hertz. So here you can see the frequency is around 200 hertz, right? And the highest voltage is 3 volt and lowest voltage is 0 volt, right? So the signal is varying between the 0 volt and the 3 volt, right? Now let us move on to the practical demonstration using the Arduino. So this is a practical demonstration of PWM signal using potentiometer and an LED. If I rotate the knob of this potentiometer in one direction, you can see the brightness level of the LED is going to be increased, right? If I rotate the knob in opposite direction, then the LED brightness would decrease. But you can see some kind of delay in the brightness level, right, as I rotate the knob. This is because most of the potentiometer are not able to exactly map the brightness values to the LED, right? But I will provide you the code of this program or the PWM signal in the description. You can try running that code in your laptop or the microcontroller. That will work fine in your system, right? So if you have any doubt regarding this project or the simulation of this microcontroller and the potentiometer LED, you can comment down below. I will try to answer that question, right? So thanks for watching this video.